Good morning. Today we are continuing on working with those factors. We are doing CO22. I can find the prime factors of a number. That's called prime factorization. So yesterday we talked about what a prime number is, those numbers that you don't have any other factors besides itself in one. And we're going to be breaking down those composite numbers to their primes. So we're going to see how to do that. So we're going to look at those prime factors as being like the DNA of a number. DNA is a person's, oh, is it not going to work? Okay, let me fix my board real quick so I can write. All right, so DNA is a person's genetic code. So it's what makes them who they are. Why would we be defining a science term like DNA in math? Because numbers have a genetic code that make each of them unique too. So your genetic code is what makes you different than your sibling, right? You're very similar to your sibling. A lot of times we can look at people and say, oh yeah, you guys are related. I can see the similarities, but you're different. Okay, everybody is unique and different because we all have a different genetic code. Numbers are the same. They all have their own specific code. What prime factors make up that number? So a prime factor are the prime numbers that multiply to make a given number. So yesterday we were talking about breaking down those composite numbers into what factors, what numbers it's divisible by. So we're going to be talking about breaking down those composite numbers to only prime numbers. To all the prime numbers, if we multiply them together, they will equal the original number. So we break down any composite numbers that we would multiply to equal it. So you can use a factor tree to find prime factors of a number. To do that, we're going to multiply prime factors. Your product should be the original number. So we're going to learn what the factor tree would look like. How we start with one number and we break it down, and we're going to make it look like a Christmas tree. And we break it all the way down, seeing how big we can grow that Christmas tree to get all of our prime numbers at the bottom. So let's see what that looks like. Write the prime factors of each number, then write at least 3 factor pairs if applicable. And I'll show you what that means. Our first number is 12. I want to break it down into factor buddies, that if I multiply them together, I get 12. Who can tell me factor buddies that would equal 12? Shantrea?
4 and 3.
4 and 3. If I multiply 4 times 3, it will equal 12. Now, I need to break it down even more. Can I break 4 down? Jack, into what numbers?
2 and
2 and what? 2 and 2, right? 2 times 2 is 4. Can I break my 3 down? No. 3 is a prime number. I can't break it down anymore. So I'm just going to bring that 1, 3, I'm going to bring it straight down. See how I'm kind of making it look like that Christmas tree? It's getting bigger and bigger as I'm breaking down my primes. Now my prime factorization, what do I multiply together to get to 12? It's all the primes on the bottom layer of my factor tree. 2 I can't break down anymore, it's a prime number. Okay, I just break it down to my primes. So 2 times 2 times 3 equals 12. 2 times 2 is 4, 4 times 3 is 12. So that is my prime factorization for 12. All the primes at the bottom of the tree, I multiplied them all together to get back up to that original number. Now it says write at least 3 factor pairs if applicable. So from here, I could do 1 times 12 is 1 factor pair, right? The number times 1. I could do 4 times 3, like I had up here. What's another factor pair? Jack? 2 times 6. Now, I chose to start off with the first factor pair somebody told me, 4 times 3. Do you think that's the only factor pair I could use? No, I could use 2 and 6 also. So I just want to show you what that would have looked like. If I went with 2 and 6, I would say, well, 2 is a prime. I can't break it down anymore. 6, I can break down to what? 3 and what, Matt? 3 times 2. Be careful. A lot of times, people, for whatever reason, 6 does this to us all the time. People will say 3 and 3 because they add the 3's together to equal 6. But 3 and 3 is not the factor pair for 6. It's 3 times 2. So always double check. Am I doing multiplication or am I adding? We always want to multiply. Now look at that prime factorization. 2 times 2 times 3. It is the same. It doesn't matter which factor buddy pair you start with. We're going to end up with the same prime factors at the end of your tree. Okay? So you can pick whichever factor pair you want to start with. It can be different than the person next to you, but you should end up with the same answer. Okay? All those factors should be the same. Do we have any questions on that? Let's do another one together, but I'm going to erase this so I can get at that 15. First thing I'm going to do is think of a factor pair for 15. What would be a good factor pair? Jude? 3 and 5. Can I break my 3 down into anything else, Rhoda? No. No, 3 is a prime. Can I break 5 down into anything else? No, 5 is a prime. So this is a very small tree. My prime factorization is 3 times 5. Okay? It was a small tree. Now I need to do factor pairs. What would be a factor pair that I could list, Michael?
1 times.
Yeah, I can always have the number times 1. What's another factor pair I can list, Rhoda? 3 times 5. So not only do I need to see your factor tree with your prime factors listed, I also need to see your factor pairs. So make sure that you're doing both. Let's look at 27. What factor pair can I use for 27? Joy? Sorry, Joy, can you say that a little louder? 3 times what? 9. Can I break my 3 down anymore? No, 3 is a prime number, so I'm going to bring that straight down. Can I break my 9 up? Yeah, into what? Claire?
3 and
3 times 3. So what would, I know I can't break 3 down anymore, so I've got 3, 3, and 3. What would I list as my prime factors? Michael?
3 times 3.
Yeah, 3 times 3 times 3. That is my prime factorization. I need to list all of the 3's. I can't just say 3. I need to list them all. Okay, because 3 doesn't equal 27. 3 times 3 is 9, 9 times 3 is 27. I need to list all those prime factors that I multiply together to get up to my original number. Am I done? Can I move on to 40? Why not? Rhoda? I need my factor pairs. So what are some factor pairs for 27? Alex? 1 times 27. What's another one? Michael? 3 times 9. Do we have any more? Nope, I only have 2 for this one. Okay. So you have to list as many as you can up to 3. Some of these might have more than 3 factor pairs. You only have to list at least 3 of them. Let's do one more together. What would be a good factor pair for 40? What was this? 10 and 4. Can I break my 10 down? Fernanda?
Yeah.
Into what?
5.
5 and 2. Can I break my 4 down?
Yes.
Jackson, into what?
2 and 2.
2 and 2. You have to put both the numbers that you're multiplying together, even if it's the same number. So that 2, I have to list it twice. 2 times 2 equals 4. All right, can I break my 5 down? Can I break 5 down into anything? Nope, that's a prime. Can I break 2 down into anything? No, it's a prime, right? 2 times 1, that's all you can have. So I can't break any of those 2 down. So what are my prime factors for 40? Rhoda?
40 times 1.
Nope,
Wait.
that's a factor pair. I haven't gotten there yet. I want to list all my prime factors that I'm multiplying together to get to 40. So what would that be?
3 2s and a 5.
So it would be 2 times 2 times 2 times the 5. That's my prime factorization. Okay, so even put that multiplication sign in there. That's what we are multiplying together to get there. Now we're going to do factor pairs. Tell me a factor pair, Rhoda.
40 times 1.
40 times 1. What's another factor pair? Jude?
20 times 2.
What's another factor pair? Michael?
10 times 4.
Now we don't have to list more, but is there more? Yeah. Joy, what's another one?
5 times 8.
Do we have any more after that one? I don't think so. So that one had 4 factor pairs, okay? So, you have to make your Christmas tree. Make sure you're filling in. If it's prime already, you just bring down the 1 number. If it's composite and we're breaking it down, you put both the numbers that you have to multiply together to get to it, until that bottom row is all prime numbers. Then your prime factors would be all those bottom numbers multiplied together. You will see sometimes people get really mathy and they say 3 times 3 times 3. That's really 3 cubed. It's the same answer, right? Because 3 cubed would be 3 times 3 times 3. So I would accept it either way. Just know that you might see that. Here, you could see it as 2 cubed times 5. 2 to that third power, as we're multiplying 2 by 2 by 2, that's 2 to the third power times 5. I would accept it either way. So you might see it either way. Any questions on the prime factorization? All right, you've got 2 rows for homework to work on. So make your factor tree. Make sure you're filling in all the numbers, breaking it down so it's just prime numbers on the bottom, writing out that list of prime factors that you're multiplying together, and writing your factor pairs. If you finish before time is up, remember we have Khan Academy due tonight. One of them is on prime factorization. Some of us have already done it. Some of us were waiting for today's lesson. Make sure you get it done. Okay, all Khan Academy needs to be done tonight. I am checking tomorrow morning. Make sure you have it done. Math packets, turn in by tomorrow to be able to fix up mistakes. Tomorrow is retake day, so be working on your practice works, turning in all practice works that you have done for me to start correcting. Okay, you don't have to turn them all in at once. If you've got a couple done, turn those in so I can correct them. If you have your signed summary sheet, turn that into the blue tray. And I have those 7 friends who still have to do their Mysteries of the Rosary. Make sure you're practicing and getting signed off on that. If you are watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day. Don't forget to like and subscribe.